I'm Guang, 15 years old, and here we will have a lesson on the techniques and applications of definite integration. So we will be solving this example for this lesson. In this example, we have a double integration on your domain or boundaries, whatever you like to call it, and it is D. So your integrand is x plus y, and then of course behind it will be a dx dy. So this D, your boundary, would be the area within y is equal to x squared, y is equal to 4x squared, and y is equal to 1. Alright, so how about let's take a look at what this boundary will look like. Now what you will see is, now let's see, the x-axis and the y-axis. Whoops, I'll just make it more straight. Alright, so x-axis and y-axis, we won't be needing much of the bottom part of the y-axis. Now, y is equal to x squared. This graph should be very well known, alright? So, that would be y is equal to x squared. And how about y is equal to 4x squared? So y is equal to 4x squared will essentially be the graph, but it is thinner, alright? So this is what y is equal to 4x squared will look like. And now of course y is equal to 1. And which parts will our area be? You have one part over here and one part over here. So that is what it would look like. Alright, well of course you could also label your graphs. Y is equal to x squared, y is equal to 4x squared, and y is equal to 1. Okay, so with this information on our boundary, we would be using the Cartesian coordinate to solve this question. Now, we would be splitting this into two different parts. One part on the left and the other on the right, alright? Now, for your area on the left, how about let's integrate with respect to x first. So integrating with respect to x, you would go from here to here, okay? Now, you can also change the function of the graphs into x is a function of y, alright? So the function on your left would be y is equal to x squared, or x is equal to square root y. But if it is just x is equal to square root y, it will be positive, which is on the right side. So on the left side it is x is equal to negative square root y, so negative square root y, and you'll have, so for that part is pretty similar, which is negative square root y over 2, and you'll have the y. So y, after you finish having one line by one line, you would go, so you have all the lines stacking together, where it will be from 0 to 1, alright? So now you can see x plus y dx dy. Okay, so this is your area on the left side. Now let's take a look at the area on the right side. So for area on the right side, your function would be from this graph, from this curve to that curve, which will be square root y over 2 to square root y, and then from 0 to 1. Then x plus y dx dy. Okay, so this is what we are going to see. Now, for your area on the left side, when you integrate, you have 0 to 1, and half x squared plus xy, and then negative square root y and negative square root y over 2 dy. So this is your area on the left, and then your area on the right. And of course, next we will be substituting in whatever values we have. So integrate from 0 to 1, and you will have y over 4, so y over 8, and then minus y over 2, then minus y to the power of 3 over 2 divided by 2, and then plus y to the power of 3 over 2, and then dy. So for the right side, you have integral from 0 to 1, and y over 2 minus y over 8 plus y to the power of 3 over 2 minus y to the power of 3 over 2 over 2, then dy. Alright, so from this part, then we can integrate each of them, or you could combine some parts first before integrating, alright? Or actually, if you realize it, since both of these are with respect to y, which doesn't really matter, but you integrate from 0 to 1, so you can kind of just combine both of these integrations, alright? Now, for your first two parts, y over 8 and negative y over 8 will cancel, so negative y over 2 and y over 2 will cancel out, but the parts behind, they will actually add together. So that means you have 2 times of y to the power of 3 over 2 and minus y to the power of 3 over 2 over 2, or you could just leave this as y to the power of 3 over 2 over 2, or if you already saw this, then this 2 and this 2 would actually already simplified, alright? So this means y to the power of 3 over 2, when you integrate it, you'll have 2 over 5, then y to the power of 5 over 2, and you integrate from 0 to 1. So you will be seeing 2 over 5 as your answer, alright? Okay, so that will be the answer we have here. Now, let's recap the entire process we had. Now, from the beginning, we are given this question. And when we draw out the different graphs, we realize they are these two little shapes, alright? So these two shapes, you can choose to integrate with respect to y first, but you have to be aware. If you integrate with respect to y first, you need to split each of these parts into 2 parts again. Okay? Or should I say, you could pretty much just have one part and then another and another. Okay? So if you want to integrate with respect to y, you have to be aware when your boundary changes. Okay? Since it can be from this function to your straight line function, or from the curve to another curve. So those things you have to be aware. Well, for our case we have here, where we integrate with respect to x first, it will always be from one curve to another curve. But you just have to be aware of the order of which curve you have. Okay, so y range, it will kind of be obvious. It is just from 0 to 1. Well, if you were to do y first and then x, then you have to again calculate whatever you have over there, which shouldn't be too hard since it is just 1 and -1. Okay, so after we know that, we write out the two parts we will see. Now in each of these two parts, we do a little bit of integration, and after we integrate them, we realize that some parts, or pretty much the entirety of these two parts, looks similar. But even if they look similar, there are some parts you cancel and some parts you add together. So with that, we would combine them and eventually get the final answer of 2/5. So that's pretty much a general thought you want to have for these types of questions, especially double integration, whatever you have. Just have to be aware of your boundaries, whatever function you have, and when this function is not exactly shown in the question, you can manipulate it a little bit. So since this question it gives us y in terms of x, we can change that into x in terms of y in order to help us solve it better. Of course, sometimes doing y first is easier, sometimes doing x first is easier. It all depends on what kind of boundaries or patterns you use. So in this case, we did use a Cartesian coordinate. If you want to use polar, well, that's up to you if you really want to try using it. Of course, it could be possible, it could be not. It depends on how you determine it, alright? So I hope for this lesson, you're pretty much clear of the entire process so far. So yeah, I'll be ending it here, and thank you for your watching.